Hi everyone, Kieran over Sapien here from Filmstorm Studios, and today we're going to have a look at how to create a root motion system that actually drives the rotation, offset, and calculates which way you should be moving on your character. And this is really good for lots of different assets that are on the Unreal Marketplace. And yeah, so we'll have a look at how to create that. But as you can see here, we've got the Unreal Project browser, and we're launching this from the Unreal Engine 4.19.1, which is the latest one as of right now. But if you come back in the future, there might be definitely newer versions. So just keep in mind that some of the variables might change that we're going to set up. So if it isn't working, I'll try and keep it up to date with what you should change to make it work. But I'm using lots of nodes that have been around for ages, so I don't think they're going to change them. So just keep that in mind in case you get through it and it doesn't actually work. But I'm sure lots of people will probably be commenting about how to fix it if we do run into that. Alright, so what we want to do, we don't want a blank project, we want third person. We're going to do this entirely in Blueprint, so you don't have to worry about coding. And we want to just call it root motion game, or you can call it whatever you want, but I'm going to call it root motion. And let's click create project. And as that goes and compiles, I'm actually going to import the animation files. You can use either our open world anim set, which is going to be releasing on the Unreal Marketplace really soon, or you could use, there's other products like the Movement Anim Set Pro that also has the full start and stop animation that you need. So what we want to do, now that this is open, we can come over to here and it says show or hide the sources panel. You can right mouse click anywhere on any folder and this will bring this up. And I'm just going to paste, actually I'm just going to grab my content. I'm going to grab the open world anim set and I'm going to pop that in here. And if you get it from the Unreal Marketplace, which will be available really soon, this will just import directly into your project, which will be really nice. So this is importing. And also this product is available on our Gumroad if you want it sooner. So that's that. So if we import that, you can see we've got all the animations here. And if we come over to the walk, you can see we have the walk stop left. And these are the ones that we're really interested in. We've got our different walks. We've got the walk stop, start right, and start here. And if you come over to the start move, we've actually got our different animations that have kind of been set up. We're going to have to come and make some adjustments because all of our animations actually need to have this box checked if we want to use the root motion, which is essentially what this tutorial is about. So this is really cool. We've got heaps and heaps of animations. Actually got over 402 animations here. So that's really nice. So if we close that out, and here we have, so if we come back to the top level content, we're not going to worry about any animations in this tutorial. We're actually just going to start building the actual calculations and how to actually take the root motion and calculate that. So if we come to third person BP and then blueprints, you'll see we have the third person character, and you know it's the blueprint because it's blue. It's got that little line under it. You can also access that by coming over and clicking on this edit. Let me bring that out. This edit third person character. And that's really good if you have lots of different blueprints in your game. You can actually come and find these ones. And you can see there's one for the sky blueprint, which actually rotates the clouds through the sky. But for now, let's just double click on third person character. And here we go. So this is actually the default thing that's all set up. This is the one we're actually going to be doing a lot of the edit. We're actually going to get rid of the whole thing and build it from scratch. Doesn't take very long, but it's really effective. But first, let's just make sure that your character is exactly the same as what I'm going to be using. So come in, we're going to work our way from top left all the way down, and then we're going to come and build out the graph. So to start off with, come up to third person character, and I'm actually just going to walk you through and make sure all our variables are the same. So what we want to do first is we actually want to enable this, and you can actually tell this isn't the default value because it's got this little arrow, and if you hover over it actually says reset to default. And when it brings in, this actually allows the player, oops, let me just drag this and chuck that into there, so that way when you click play it brings up a little window. So basically what that button does is that stops the player from rotating. So if I enable this, theoretically this should actually block the character's rotation. And this is important for actually driving the root motion. So this is one thing that we need to make sure has been checked. Okay, now let's come down to the capsule component. Very good. And let me just bring this one up. I'm pretty sure there's nothing we actually need to change in this one. So that one's all good. And these are all the default values as well. So just if you want to double check your ones to my ones, that way we can you make sure that everything's working the way you want it. And again, mesh is fine. Camera boom, we actually want to adjust a couple of things in here. What we want to do first, let me just bring this around so we can see. What we want to do, let me zoom up, is we actually want to bring this arm and raise it up. So let's bring it up to around his shoulder. So that way the camera sits a bit higher on him and looks really, makes the camera feel a bit more connected to the character rather than sitting around his hips. So you can see that it's already a bit higher. And also let's make this Y 70. So now if we compile and run, you can see now it's on the side a bit, which makes the camera seem a bit nicer. Okay, one other thing that I like to do is let's enable the camera lag, and this actually, let me just put 50-50 and then 10, so you can see 50-50-10. And this actually makes the camera feel a lot heavier and more realistic, and actually interpolates between where the character's moving, and then takes a tiny little second to catch up, so that way the camera doesn't feel super connected to him the whole time. So if we click play, and it doesn't feel like much, but seriously, it makes a massive difference. And if you want the camera to feel even more laggy, you can just bring these values down a little bit, and it will make it feel heaps better. Okay, finally, let's come to character movement. This is probably the most important one if you had to change anything. I mean, you have to change each value, but yeah, this is definitely the one to definitely make sure you fix. Okay, so let's come down, and we want to focus on this this walking, and we want to change the max walk speed to 550. And also, if we come down even further, this is probably the biggest one that we need to focus on, is orient rotation to movement. And if we uncheck that, basically when we want the character to rotate correctly, we're actually going to be turning it dynamically on and off as we go. So that's also that. And also if we come down, I believe we're also going to change this one, which is allow physics rotation during root motion. So we're going to be turning this one on and off as well through the script. But don't worry about that. We're not going to cover that in this tutorial. We're going to focus that on the next part when we get to the animation blueprint. So let's just go ahead and get started making the variables. So what we want to do is let's click this new little plus variable. And as you can see, this brings up this little thing. It says new var _0. And there's two ways we can change the variable type. You can come and click here, and you've got all these ones. And then you also have all the object references, which we probably, not sure if we'll use. I can't remember if we use it in the animation blueprint. I'll double check. But we'll get to that when we do the animation blueprint. But for now, we want the first one to be a Boolean. And you can also change it just over here by clicking the color. So we want it to be a Boolean, and we want to call it is sprinting, question mark. We're going to come back and create this one. Let's come and create another one, and we're going to call it input X, and we want to make it a float. And let's create one more, actually two more, input Z and direction. And that's all we need for this. So let's click compile. You can see that the values now appear in here. That's what we're going to be changing on the fly. Now let's come to the event graph, and we're going to highlight all of this, and we're going to blow it away. Let's click delete, because we're actually going to come and actually develop our own system from scratch. Okay, so right mouse click, and you'll get this all actions for this blueprint. Now, one thing that's super important that I like to point out is this context sensitive. If this isn't checked, you'll get a bajillion options, and half of it's actually not relevant to what you're doing. So if you make it context sensitive, it makes it heaps better. right mouse click, and we're going to start by typing move forward. And these are two access events that have been predefined in the project settings. So if you come up to edit project settings, so if you're just wondering how this is all incorporated, if you come down to input and then access mappings, you can see that we have all of these, and you can see that one's called move forward, and then this one's move forward. And all of these are being driven by WS, so it's backwards and forwards, the left thumbstick on the controller, and also up and down on the keyboard, and also the left thumbstick on the gamepad. So basically this is how you come and set up all the input. It's the exact same as the input settings on Unity. You'd have to come and define what you want the player to be pushing. But this actually makes it a lot easier to just come and pick out what things you want to actually turn on and off. And then you can see for the jump, use just the space bar or the face button. Okay, so now that that's done, let's right mouse click, and we want to create a move right, and make sure it's an axis of it. Make sure they're the red ones. Cool. Now let's drag off here, and we're going to set the input Z, which is the backwards and forwards variable. And we want to drag off here and set the input X. Excellent. Now let's drag off here, and we want to debug this so we can actually test what's happening. So let's break that. We don't want it to be set to the duration. We actually want it to be telling us what the variable is. Let's expand this and make the duration 0, so that way we're not getting a heap of variables appearing on the screen. And then let's come and drag off this purple one, and let's type in append. And this is a really powerful thing for debugging, because it actually lets us type things to appear in front of our variable, so that way we can actually know what variable it is. Because say if I did this right now, it would all just be 0, and you'd have no idea there'd just be all these random numbers on the side of the screen. So what we want to do is actually come and drag this into B. Let's break A, and in A we want to type input X. So in the debug log, when we're playing the game, it will actually say input X space, and then it will show us the variable, which is really nice. So let's just narrow this down. Click there. Let's copy this, paste this here, connect this little green dot here, and make sure you also connect the node to here. And let's also change this to make sure this says input Z. Groovy. Okay, so that's basically that. Now, one big thing that I like to make sure we do now is let's actually set up the system that calculates the input direction relative to where the player is looking. So how do we do that? Well, what we want to do first is let's drag off from the move forward. And what we're going to do is we're going to say make vector. Excellent. And then from this make vector, we want to actually grab another one from move right. And we want to times it. You can actually say times is above the 8 button. So you have to press shift and then the 8. And that will bring up this little star. And we want to say float by float. And let's drag this into Y. So make sure it's in Y. And we want to times this by -1. Excellent. Okay, so now let's come and drag off the vector, the new vector we just made, and say rotation from X vector. Excellent. And now let's drag off from here, whoops, and drag it up to here and say delta rotator. Let me just bring this out forward. Oops, let me just bring this out so that way it's kind of flowing a bit nicer. I don't like it when lines overlap. It makes it really hard to read, apart from like these little ones, but I mean, that should be fine. Okay, so let's break it from A. We don't want it on A, we want it on B. And then we actually want to create another delta rotator on that delta rotator to calculate an angle between two other things. And those two other things, we're actually going to be getting the get world rotation of the follow camera. So you can see that it automatically connects that all up for us. And we also want to get the world rotation for the capsule component. Groovy. Okay, now from this rotator, let's break it. Break rotator. And then let's connect the Z to set direction. And now we need something to actually run this direction every frame, because unfortunately that's something that just needs to happen, because we always want to know what direction the character is looking relative to where the input is. I mean, that's relative to the game, so it's pretty important. So there's one way you can do it, which is really handy. Let's right mouse click and say event tick. Now I know a lot of you will be like, oh, well, event ticks are really expensive in the game, and it takes away a lot of the performance sometimes. That's if you use a sequence. So if we use a sequence and plug 0 into here, that way if you need to use an event tick again, instead of creating a new one, which then runs double the event ticks, you can actually use a sequence which only runs one event tick over a period of sequences, which is really handy, instead of running all the different event ticks all the time. So if you have another one, you can always just come and drag into here if you need a new event tick. Excellent. So let's also debug this variable. So let's come and just grab these three again, and let's paste them here, connect the float into here, and let's make our debug direction space, and then plug the input into here. So that way it's running. Okay, so guess what? We're actually almost done, which is really exciting. What we also just need to do is just get the actual forward vectors and right vector for when the root motion isn't working, which is usually when we're in the air. So we want to calculate which way the character is actually pressing. So to do that, let's right mouse click, get the control rotation, and from here let's drag off. We want to break it. Now, one thing I want to show you is you don't actually have to break every single thing if you want to access a specific variable. If I just break this one to break the link, you can actually right mouse click here and say split struct pin, and that's how you can actually get a break just here without actually using a breaking thing. So that way it actually just separates it, and you can use separate variables here. But I personally like to just break it, so that way I actually know that that's what I'm doing. So you don't have all these random 50 billion pins everywhere, and you kind of lose control of it. Okay, so we want to use the Z yaw, and we want to make rotator. And again, it places it into the first variable, so we want to break that link and place it into Z. Okay, and then from this one, we want to get forward vector. And we also want to get the right vector. Okay, so let me just bring this down. Sorry, I'm just going to drag it down a little bit, so that way we have more space. Okay, and then from here, we're going to drag it and say add movement input from the forward vector. And then from this one, we're going to say add movement input again. Now we just need two things to actually run it, and what this will be for this one, we want to plug it into the print string, and you can see that's kind of overlapping. So if you double click on the line, you can create what's called a reroute node, so you can actually make it look a lot nicer. But sometimes the blueprint just can't calculate the line correctly and makes it offset, but don't worry, we know that it's straight. We know that it looks good. So what we want to do is actually plug this into input X, the scale value. So plug that in there. And also let's clean this one up so it's a bit easier for us to follow. That one's also fine. Okay, and then the same thing goes for this one. We're actually going to plug the direction print string, this one, into here. And then we also want to plug the scale value into the input Z. So let's drag input Z to scale value. And let's also just create a reroute node so it's a bit neater. Let's drag it up a bit. There you go. So there you go. So that's our full blueprint created that handles all the calculations. Let's just first comment this together so that way it's all separated. So let's press C. And then we can come in and create a comment to ourselves. We're going to call this the root motion movement calculator for direction of input relative to where the player is facing compared to the camera forward vector. It sounds like a lot, but that's technically what we're doing. We're getting the input relative to where the player is facing compared to the camera forward vector. And we can also come and change the color. Can make it like a soft blue. That makes it a bit easier on our eyes, so we can look at our neat work that we've just created. Yeah, so that's all good. So what we can do now is we can actually compile. Fingers crossed, it's all good. We can get the green tick, and let's come and click play. And now you can actually see those variables in the top left corner. If you go Shift F1, you can release the mouse, and that way I can point it to you. So you can see we have input X, input Z, and direction, which was getting created from these different append nodes that we created. So if I click in here, let me show you the magic now. So if I press backwards, I'm getting -80, or 180, sorry, and -1 in the input Z, and that's +1 for forward, -1 for backwards. This should be -1 for left and +1 for right for input X. And you can see the direction is also updating correctly. So we've got +90, -90, 0, 180, 45 for right forward, and left forward is -45. Back left is -135, and this is 135. And magic is also that when we rotate the camera, it's always giving us the correct angle that we want to use. So this is really exciting, and also jumping. And then you can see that we're allowed to control the character that when we're in the air, which is also cool. So there we go, we've got all the math sorted. So in the next tutorial, we're going to cover how to actually plug this into the anim blueprint, which the animation blueprint actually drives the animations. So that's where we do a lot of the magic and calculate the speed that we're pressing and do all that magical stuff. So thank you so much for watching this tutorial. I hope you found it interesting and helpful. Please look out for the next tutorial, which will probably be dropping the day after this one. And I'll catch you all, everyone, and everything for thank you.